Friends, welcome to Abhivakti India's Future Classroom. In today's episode, we will see the problems on probability that are asked in the IBPS PO examination. So welcome to the part 1. Friends, what is probability? Probability deals with numerical measures of the degree of uncertainty. The theory of probability originated from gambling in the 16th century. Today this theory has become so rich and developed that it is being widely used not only in all branches of science, commerce, biological sciences, weather forecasting, but also in different branches of engineering, for example, information theory, automatic control theory, ship behavior in navigation, etc. Before going into the topic, we will see first the basic concepts and terms that are related to the theory of probability. So what is the scope of probability to occur? The probability will occur only and only when there is an event. So if there is an event, then only the probability can occur. So what is event? Event is a tossing of coin, drawing of a card, rolling of a dice. Tossing of coin, that is known as event. Drawing a card from the 52 cards is an event. Rolling a dice or throwing a dice is also an event. And for every event there should be a outcome. For example, if we toss a coin, the result will be either head or a tail. This should be tail. So if we toss a coin, the result will be either head or a tail. So tossing a coin is an event and its outcome will be either head or tail. And this outcome should be equally or likely. What do you mean by equally or likely? It means that if you toss a coin, there are two outcomes, head or tail. Two possibilities are there, and both the possibilities have equal chances to occur. Head has 50% of chances and tail has 50% of chances. So both have the same chances and therefore every outcome should be equally likely. For example, if you roll a dice, dice has 6 numbers on it, 1, 2, 3, 4, 5, 6. So the 6 outcomes are possible. When you roll a dice, either it will be 1 or 2 or it may be 3 or it may be 4 and so on up to 6. The probability or chances of occurring 1 to the upside will be 1 by 6. The chances of occurring 2 will also be 1 by 6 and the chances of occurring 3 will also be 1 by 6. It means that every outcome has equally likely chances to occur. So the outcome should have equally likely chances and these outcomes should be countable. So remember that the scope of probability to occur is that there should be an event, then that event should have outcome and that outcome should be equally or likely and that outcome should be countable. Now friends, we will begin with the first question. It is on the screen. A bag contains 3 red, a bag contains 3 red, 5 yellow, 4 green balls. 3 balls are drawn randomly. What is the probability that the balls drawn contain balls of different colors? Exactly 2 green balls and no yellow ball. As we know that the probability is calculated by a formula P of E is equal to favorable outcomes upon total outcome. So here we will have to find the total outcomes and the favorable outcomes. The total number of balls are total number of balls that are equal to 3 red plus 5 yellow plus 4 green, that is equal to 12. So total balls are 12. Out of these total balls, we are randomly taking out 3 balls. So the number of possible outcomes will be 12C3. This we have seen in the permutation combination. Total balls are 12. Out of that total balls we are taking out 3. So the total possible outcomes will be 12C3. This we can solve as 12 factorial by 3 factorial into 12 minus 3 factorial. So that is equal to 12 factorial upon 3 factorial into 12 minus 3, that is 9 factorial. So this will be 12 factorial means 12 multiplied by 11 multiplied by 10 multiplied by 9 and onwards will be 9 factorial. We are stopping here only because 9 factorial is already in the denominator. So upon 3 factorial will be 3 into 2 into 9 factorial as it is. So 9 factorial will get cancelled and it will be 12 into 11 into 10 upon 3 into 2. 3 2s are 6 and that 6 1s are 6, 6 2s are 12. So it will be 2 into 11 into 10. So the total possible outcomes that will be equal to 2 into 11 into 10. So which is equal to 11 2s are 22 into 10, that is 220. Therefore total possible outcomes that is equal to 220. Now see the first question. That balls of different colors means one ball should be red, other ball should be yellow and third ball should be green. When we take out 3 balls randomly, one ball should be red, other ball should be yellow and the one ball should be green. It means each are dependent on one another. So this is a dependent case. If it comes red, yellow, yellow, then this is not favorable to us. So this third should be green, means one should be red, one should be yellow, one should be green. So these 3 are the dependent example of dependent case. And so out of this, so there are 3 red balls. So the favorable will be 3C1 because 1 we require. 1 is favorable out of 3. Similarly, for yellow, how many balls are there? 5 balls are there. So it will be 5C1 because 1 out of 5 is favorable. And third one is green, and so green are 4 green balls, so it will be 4C1, and since it is a dependent case, we will multiply this. So which is equal to 3 multiplied by 5 multiplied by 4. So that will be equal to 5 4s are 20 and 23s are 60. So these are the favorable outcomes, these are the total outcomes, and therefore required P of E, that is equal to 60 by 220. So 0 0 will get cancelled, so it will be 2 3s are 6, 2 1s are 2, 2 1s are 2, so it will be 3 by 11. So the required probability to occur balls of different colors will be 3 by 11. Friends, here avoid these steps and directly have or develop a habit of writing this step, and then finally this step. Now the second question is exactly 2 green balls. We have calculated total possible outcomes, that is equal to 220, and now our favorable are exactly 2 green balls. Now these 2 green balls will be selected out of 4 balls, because there are total 4 balls, and out of that 2 green balls will be selected, and the third ball that will be selected from the others, that is other than green balls, that is yellow and red, means the other one ball that will be either red or yellow and will be selected out of 8 balls, 5 plus 3. Therefore, number of favorable will be out of 4, 2 balls, so it will be 4C2 multiplied by 8. Out of 8, 1 will be there, so 8C1, which is equal to 6 into 8, and that is equal to 6 8s are 48. So favorable are 48, total are 220. Therefore the probability of the event, required event, that will be equal to 48 divided by 220. That is equal to 12 by 55. Here how to write this and this you learn from the combination part, that is 4C2, that is 4 factorial upon this 2, so 2 factorial multiplied by, it will be 4 minus 2 factorial, so that is equal to 4 factorial upon 2 factorial into 4 minus 2, that will be 2 factorial, so which is equal to 4 factorial can be written as 4 into 3 into 2 factorial upon 2 factorial into this 2 factorial can be written as 2 into 1, that is 2. So 2 factorial will get cancelled, This 2 ones are 2, 2 twos are 4, so which is equal to 6. This is the way of solving, but develop a habit of writing it directly. Now the third question is no yellow ball. Here we have already calculated that the total number of outcomes, that is equal to 220. Now we have to find the possible favorable outcomes. Now here it is said that there should be no yellow ball. It means there will be a red ball or green ball. Red balls are 3, green balls are 4, and in total there are 7 balls. So here, out of 7 balls, 3 balls are selected. 3 balls are drawn. And therefore, the possible favorable events will be equal to, out of 7, 3 are drawn. So that is equal to 7 factorial upon 3 factorial into 7 minus 3 factorial, so which is equal to 7 factorial upon 3 factorial into 7 minus 3, that is 4 factorial. Now here 3 factorial is there, 4 factorial is there, so 7 factorial, that we will write up to 7 multiplied by 6 multiplied by 5, because into 4 factorial. This upon 3 factorial can be written as 3 into 2 into 4 factorial. So 4 factorial will get cancelled, and here it will be the 2 ones are 2, 2 threes are 6, 3 and 3 cancelled, so 7 5s are 35. So the favorable outcomes are 35, and therefore the required probability is equal to favorable outcome upon total outcome, that is 220, so which is equal to 7 by 44. So the required probability is 7 by 44. The next question on the screen is that from a pack of 52 cards, 2 cards are drawn. What is the probability that it has both the SS, exactly 1 queen, no honors card, no digit card, and 1 king and 1 queen? Here we will first solve the first question, that what is the probability that it has both the S's. In a playing card, the total number of cards that is always equal to 52, and the number of cards drawn, that is equal to 2. Since there are 52 cards, there will be 52 outcomes, but we are drawing out 2 cards, and therefore the number of outcomes will be equal to 52 C2, because 52 cards are there, 52 outcomes are there, and out of that 2 we are taking out. So which is equal to, it will be 52 factorial upon 2 factorial into bracket 52 minus 2, that is 50 factorial. So if you solve this, we get it as 52 into 51 upon 2, and that is equal to 26 into 51. So the total outcomes are 26 into 51. We know that the probability is calculated by the formula that favorable outcome upon total possible outcomes. So the total possible outcomes are 26 into 51, and now we will find the favorable outcomes. So the favorable outcome, that is equal to, now we want both the S's. In all, in playing cards there are 4 S's, one from club, one from heart, one from diamond, one from spade. So in all there are 4 aces, and out of that 2 are favorable to us, and so the total favorable will be 4C2. 4 are the total number of aces, and out of that 2 are favorable for us, so it will be 4 factorial divided by 2 factorial into 4 minus 2, that is 2 factorial. If you solve this, you will get it as 4 into 3 upon 2, and 2 ones are 2, 2 twos are 4, so which is equal to 6. So these are the favorable. So the required probability of both aces will be equal to favorable outcome, that is 6, upon total outcome, that is 26 into 51, 26 into 51, that is equal to 1 by 21. So the required probability is equal to 1 by 21. Now see the second question. What is the probability that it has exactly one queen? We have already seen that the total number of outcomes are 26 into 51. Now we will find the favorable outcome. One queen. How many queens are there? Of course, there will be 4 queens in a pack of 52 cards. One from diamond, one from heart, one from spade, and one for club. In all, there will be total 4 queens. So as far as queens are concerned, the favorable outcomes will be 4C1, because out of 4 queens, 1 is favorable for us, so which is equal to 4 factorial upon 1 factorial, that is the thing, and so 4 minus upon 3 factorial, 4 minus 1, that will be 3 factorial. So 4 factorial, that is 4 into 3 factorial upon 3 factorial, so this will get cancelled and it's equal to 4. So if it is 4C1, it will be always 4. 6C1, remember it will be always 6. 7C1, it will be always 7. So the favorable outcomes here will be 4 as well as far as queen is concerned. But the second card will be from the remaining cards, and that is 52 minus 4, that is equal to 48 cards, because we are drawing out 2 cards. So out of that 2 cards, one will be queen and the other card will be any other card. So this any other card will be from out of the 48 cards. So the favorable cards for the second card, that will be equal to 48C1, because 1 is favorable for it out of the 48 cards, so which is equal to 48, and therefore the total favorable cards, that will be equal to 4C1 plus 48C1, because here both are dependent, and so which is equal to 4 into 48. So the total favorable cards are 4 into 48. Total number of outcomes are 26 into 51. Therefore the required probability, that is equal to favorable, that is 4 into 48 divided by 26 into 51, which is equal to 32 by 221. So the required probability in the second case is 32 by 221. The third question is that what is the probability that it has no honors card? What are honor cards? Ace, King, Queen and Jack are called as the honors card, and King, Queen and Jack, these three are called as the face cards. These are the honors card. So from each stack there are 4 stacks: spade, club, diamond and heart. 4 will be from this, 4 will be from this, 4 will be from diamond and 4 will be from heart. So there will be total 16 honor cards. And as far as face cards are concerned, 3, 3, 3 and 3. So there are 12 face cards. Remember this. So 16 honor cards. As far as this question is concerned, we are talking about honor cards. So there are 16 honor cards. Here the total number of cards, as we have calculated, is 26 into 51. Now we will calculate the favorable cards. Here it is said that no honor cards, and therefore these 16 cards are not favorable. So the favorable cards will be 52 minus 16, that is equal to 36. So the favorable cards are 36, and out of these 36 cards we are drawing out 2, and therefore the number of favorable cards will be 36C2, because 2 are favorable for us out of 36. So it will be 36 factorial divided by 2 factorial divided into 36 minus 2, that is 34 factorial. So this will be 36 into 35, because after that it will be 34 factorial. This 34 factorial will get cancelled and it will be 36 into 35 upon 2 factorial, that is 2. So which is equal to 2 18s are 36, and so it is 18 into 35. And therefore the probability that is required is total outcome, that is 26 into 51 upon 18 into 35. So which is equal to 105 upon 221, and therefore the required probability is 105 upon 221. The next question is, what is the probability that it has no digit card? It has no digit card. In the playing cards, 1 to 10 are the digit cards, and therefore Ace, King, Queen and Jack, these are not the digit cards, and therefore from each stack means from each diamond, heart, club and spade, the 4 cards will be the no digit cards, and in all there will be 16 no digit cards, and therefore these 16 are favorable for us. So the favorable outcome that will be equal to, out of 16, 2 we are drawing out, so it will be 16C2, because there are 16 favorable cards, out of that 2 we are drawing. So the total possible favorable outcomes will be 16C2. So it is 16 factorial upon 16 minus 2 upon 2 factorial into 16 minus 2, that is 14 factorial. So we will take this up to 15. So it is 16 factorial, that is 16 into 15 into 14 factorial, that 14 factorial will get cancelled, and so what we will get, 16 into 15 upon 2 factorial is 2. So 2 8s are 16, and which is equal to 8 multiplied by 15. So the favorable outcomes are 8 multiplied by 15, and therefore the required probability, that is equal to favorable outcome, that is 8 into 15 divided by total outcome, that is 26 into 51. So which is equal to 20 by 221, and so the required probability is equal to 20 by 221. Now we will deal with the last question, that is, what is the probability that it has one king and one queen. We are drawing out 2 cards, out of that 1 card will be king and other card will be queen. Total king cards are 4 and queen cards are also 4, and so as far as this card is concerned, our favorable probability will be 4C1, because 1 card is favorable out of this, and here also the favorable will be 4C1. So the total will be 4C1 into 4C1. Therefore the number of favorable outcomes, that will be equal to 4C1 multiplied by 4C1, which is equal to 4 multiplied by 4, and so that is 16. So favorable are 16 and total outcomes are 26 into 51. Therefore the required probability is equal to favorable upon total, that is 26 into 51, which is equal to 8 upon 663. So the required probability is equal to 8 upon 663. Friends, now here we will stop, and in the next session we will see the questions related to dice and the coins. I hope you must have enjoyed this session. If yes, please like it, share it with your friends, and subscribe to the channel so that you will get connected with me, and share it with your friends. Thank you very much.
Friends, you might have enjoyed this video. Then go to thumbs up button and click. Then go to share tab and share with your friends on Facebook, Twitter, Google Plus and many more. And to get the updates right in your mailbox, don't forget to subscribe. Thank you very much.